Welcome to Coast Talks. My name is Julie Angus. I'm on the board of Coast and the CEO of Open Ocean Robotics, a Victoria-based maritime robotics company focused on ocean data analytics. I am opening today's event from the territories of the Lekwungen peoples, today known as the Esquimalt and Songhees nations. Coast is committed to working with First Nations and to respecting their long-standing relationships to the lands and waters, as well as their leadership as innovators and stewards of these territories. I invite everyone joining today to take a moment to reflect on the territory from which you are joining today's conversation. For those new to Coast Talks, COAST stands for the Center for Ocean Applied Sustainable Technologies, a new ocean innovation hub based in Victoria, BC. COAST's mission is to drive inclusive prosperity in the British Columbia sustainable blue economy through entrepreneurship, innovation, and expansive partnerships. The COAST Talk series was launched to showcase some of the organizations, innovators, and companies working hard to build a sustainable ocean future. Today's talk is one of 6. You can sign up for upcoming talks on our website, canadacoast.ca, and view past talks on YouTube. Today, I'm delighted to introduce you to Dr. Lisa Kalinchuk, the moderator of today's conversation. Dr. Lisa Kalinchuk is the Vice President, Research and Innovation at the University of Victoria and is a member of COAST's Advisory Board. Prior to this appointment, she was the Associate Vice President, Research from 2017 to 2019. As VPRI, Dr. Kalinchuk is responsible for the research portfolio at the university, which includes strategic leadership to implement an ambitious vision for research and innovation at the university, service to support faculty and student grant applications and scholarly ethics, and external outreach to promote the university and develop global partnerships. Before joining the University of Victoria, Dr. Kalinchuk was a professor in the Department of Medicine at the University of Saskatchewan, where she also served as Associate Dean for Interdisciplinary Health Research and Special Advisor to the Provost. As an administrator, she has led and contributed to several major strategic planning exercises, including an academic program prioritization process, a new university strategic plan, and the development of a novel governance structure to manage a new academic health sciences complex shared by 5 different faculties. Thank you, Lisa. Dr. Kalinchuk.
Thanks very much for the introduction, Julie, and good morning, everyone. I'm really delighted to be here today and excited to have a conversation with our 3 expert panel members about tidal energy in British Columbia. I was asked in these just first introductory comments to explain why I thought this would be a good topic for a COAST seminar. And so I guess the first question to start with is, why talk about tidal energy? I guess for me, it's an important topic because it brings in all of the ocean-related innovation and entrepreneurship that COAST is intended to support. But it also addresses our growing need to find alternative sources of energy in the face of the current climate crisis. The heat dome of this past summer showed us that climate change is here, it's in BC, and it's very real. Obviously, the path forward is complex and layered, but one essential component in combating climate change is a move away from fossil fuels into other sources of energy that are renewable and environmentally friendly. I'm excited about tidal energy because this is an area where the University of Victoria has significant research expertise through the work of Brad Buckham and his team. And there are also several local companies working on related technologies, as you will hear today. Our panelists will explain some of their work to help you understand the potential of tidal energy in BC, but also to explore the challenges we face to get there. In the time we have today, we'll examine what BC has done in the past, what is happening now, how other jurisdictions have approached or are approaching tidal energy, and how these past experiences can inform the next steps in British Columbia. We'll also talk about demand There are more than 30 remote towns on the BC coast, including numerous Indigenous communities that still rely on diesel generators for power. These communities need innovative solutions. We know from Brad Buckham's work here at the University of Victoria that British Columbia has over 90 square kilometers of practical resource that is a technically feasible tidal resource. We also know from reports published by BC Hydro that there are 617 megawatts of capacity in 12 identified sites. There is much more capacity when we look Canada-wide. According to Marine Renewables Canada, Canada has approximately 40,000 megawatts available on our 3 coastlines. Of course, not all this power can be realized, but it does exist. So that leads us to the hard part, tapping into this available energy and delivering it to those remote communities that need it. There are several challenges that many of you in the audience will be familiar with, including the added cost and complexity of construction in remote communities, the storage of intermittent power for later use, the economic model and high cost associated with tidal power installations, and of course, the financing for such projects. These challenges are not unique to BC, as we've seen projects like the Cape Sharp tidal turbine project in Nova Scotia fail because the company decided that the investment was too significant and the timeline too long to pursue the project. And unfortunately, that turbine is now sitting at the bottom of the ocean and it's not clear who's going to remove it. So I think this sets the backdrop for a good conversation with our panelists about the next steps in BC. Each of our 3 panelists will deliver a 10-minute presentation, and then we'll open the Zoom room for your questions. Please use the Zoom Q&A function to submit your questions. This session is being recorded, and you can submit your question anonymously if you prefer. So let's get started. I'm very pleased to introduce Ben Whitby as our first speaker. Ben is the program manager at PRIMED, the Pacific Regional Institute for Marine Energy Discovery. He holds a PhD from Cardiff University and an MEng degree in electronic engineering from the University of Exeter. He has a background in renewable energies, power electronics, and power systems. Ben will speak about the integration of tidal power with microgrids and a demonstration project in the Blind Channel. Over to you, Ben.
Hi, good morning, everybody. Just going to share my screen up. There we go. I hope you've all got my screen. Yes, good morning, everybody. Thank you for the introduction. My name is Ben Whitby. I currently work within the Pacific Regional Institute for Marine Energy Discovery, which is a bit of a mouthful, so we usually just refer to ourselves as PRIMED. We are a multidisciplinary research group cited at the University of Victoria with a specific focus on accelerating the development and adoption of marine renewable energy technologies on the BC coast. The group has a fairly long history in BC, which goes back at least 15 years. We like to think of ourselves as being the connective tissue between the tidal energy technology developers and BC's coastal remote communities. We see these communities as being the most likely beneficiaries from the development of this technology on the BC coast, at least in the initial stages. And there are a lot of reasons for that, which I will elaborate on later in the presentation. So first of all, I'd just like to give you a bit more of an introduction to PRIMED. What is our research capacity? What do we do? We like to define our capabilities within 4 main areas. The first being community engagement. As I said, we have a fairly long history working on the BC coast. And over those years, we have worked in partnership with numerous communities, predominantly, but not exclusively, First Nation communities. And we like to think that over the years, we've become pretty good at doing that. The second area where we have a lot of expertise to offer is in resource assessment, using a combination of field measurements, computational models. we are able to carry out resource assessments with the aim of quantifying the tidal resource around the BC coast. This enables us to provide communities and potential developers with high quality resource data. And that really is the foundation for any project. That's where you need to start. The third area is technology performance modeling. So we can work with technology developers in a second party assessor role. And because we have no stake in those technologies, we are able to complete unbiased assessments. And the final area is grid integration. Primed can help communities navigate the complexities of building cost-effective and reliable hybrid microgrid systems that combine not only renewably generated power, but also traditional power sources as well. So, in summary, Primed answers the following questions, or at least we try to. There is interest from the community at multiple levels, so how can we get a project started in that community? What capacity would be appropriate for the community? How much power do they need? What is the load? What is the nature of the load? How can we assess a project's potential from both a practical and an economic perspective? And finally, how do we fund projects? That can often be quite complex, navigating the various funding mechanisms, etc. And we can advise communities and assist them on that. So, having introduced you to Primed and given you a bit of an overview of what we do, let's take a quick step back, as I realize some of you may not be terribly familiar with what tidal energy actually is. So tidal energy devices aim to exploit the natural ebb and flow of coastal tidal waters in order to generate renewable power. They are, for all intents and purposes, underwater wind turbines. Now, the image you see on that slide there is probably a little bit dated now. It's a picture of the CGen tidal turbine, which is very much where the tidal energy industry started. Back in 2008, when this turbine was deployed, it was a pioneering project. It was the first commercial grid-connected tidal turbine, and it operated for over 5 years, generating about 5 gigawatt hours of tidal power. And I actually ended up working for the company that was behind the original design of that turbine. So that's the other reason I like showing the picture. The turbine was eventually decommissioned in 2019, but as a proof of concept, it was, for all intents and purposes, a very successful project. So what makes tidal energy relevant in BC? And what makes it an attractive proposition for communities in British Columbia? Well, a large number of communities in BC are remote and they are not connected to the main utility grid. They are reliant, in a lot of cases, solely on diesel generators as their only source of power. And this has numerous environmental, social, as well as economic problems associated with it. These are high-cost power markets. These communities are often paying much more for their electricity than communities connected to the main utility grid. And that creates issues with energy poverty and all kinds of things like that. So this slide just puts a few numbers on the communities I'm talking about. And I think in the introduction from Lisa at the top, she sort of touched on this. Yeah, you can see there are quite a few of these communities in BC, and a large chunk of those communities are solely reliant on diesel as their power source. So where is the tidal resource in BC? Studies have shown that there are numerous potential tidal sites, many of which are in close proximity to these off-grid communities. So this is just showing southern BC here, and you can see a lot of potential sites, both on the west coast of Vancouver Island and on the east side of the island, as well as on the mainland. And it's a similar picture in northern BC. There are a lot of potential sites on Haida Gwaii, as well as on the mainland coast as well. So of all the potential sites on the BC coast, I wanted to introduce two case studies. And these are two locations where Primed over the last few years has been very active and where tidal projects are currently being explored or are under development. The first is the Blind Channel Wilderness Resort. This is a resort occupied year-round. It's located on West Thurlow Island, which is a little ways north of Campbell River. It's to the northeast of Campbell River on the east side of Vancouver Island. And in 2017, a 20 kilowatt floating tidal turbine was actually deployed at this location. The objective of that deployment was to try and prove the concept really. It was to show that a small kilowatt sized tidal turbine could be integrated into an existing diesel-based microgrid. I believe the device actually operated for about 9 months, and as a proof of concept, it was largely successful. The device was taken out the water in 2019, and that was largely due to the funding requirements to keep it going, and that funding simply wasn't there. But as I say, as a proof of concept, the project was largely successful. And this slide just sort of emphasizes and reinforces some of the motivations for adopting tidal power at Blind Channel. Reducing diesel usage and therefore cost is obviously right up there. But there's also a strong desire from the owners of BCWR to portray a greener image of the site. They market themselves as a sustainable wilderness resort. And the fact that they, at the moment, rely on diesel generators to power all their operations kind of contradicts that a little bit. So they're keen to try and portray a greener image. So during the deployment of the Mavi turbine, the local supply chain was engaged. Most of the support vessels, commercial dive teams, as well as docking facilities, etc., were all mostly came from Campbell River. The Campbell River Marina was used for equipment loadout, and most of the vessels and support came from that area. So it was all really locally sourced. Despite the turbine being removed in 2019, Primed continues to be active at the Blind Channel site. We have ongoing resource assessment work. We just recently recovered an instrument which was measuring currents at the site. And we also have monitoring equipment which we're using to monitor and analyze the electricity usage on the site. And options are currently being explored to develop Blind Channel as a testing value for commercial developers. And that is currently moving ahead. So hopefully we will be seeing another turbine in the water at Blind Channel in the next few years. So the next case study I want to introduce is Quatsino Narrows. Quatsino is a small end-of-line community currently serviced by BC Hydro. Despite being grid connected, reliability of supply is still a big issue in this community. And there's a little map there showing it's a community on the northeast side of Vancouver Island. So this slide just reinforces some of the community motivations for pursuing renewable energy within the Quatsino area. These motivations largely revolve around reliability issues, as well as potential economic benefits that renewable energy projects could provide to the community. So a pre-feasibility study at Quatsino was conducted in 2019, and it showed that there was a promising resource available. And options are currently being explored that would enable a more detailed feasibility study to be undertaken with the aim of eventually developing a tidal energy project at the site. So finally, in summary, just to wrap up, it's worth noting that a lot of the communities I've introduced, for the most part, are small loads. These are not locations where you would be looking to deploy megawatt-sized utility-scale turbines. These locations are where turbines on the order of kilowatts, with the ability to function in relatively shallow water depths, would be most appropriate. And this is a key differentiator between tidal projects in BC and those currently being explored on the East Coast, where utility scale is very much the order of the day. And that's important to emphasize that. It's also worth noting that these microgrids may already contain other renewable energy sources, such as solar, wind, etc. And these different sources need to be coordinated to optimize the benefits. There is no reason why tidal power can't work alongside and complement other renewable sources. It doesn't need to be competing. And that's a lot of what we do here at Primed, is microgrid research and looking at how we can increase the penetration of tidal power into these grids and optimize the use of that power. And finally, tidal is not just relevant in off-grid communities. I introduced Quatsino, which is actually a grid-connected community, and there are potential benefits to both off-grid and grid-connected communities in BC. And I think that's my last slide, so I'll leave it there.
Thanks very much, Ben. And for those of you who may have questions, you can please use the Q&A function or enter them in the chat, and we'll hold all of the questions to the end, just to give all of the speakers a chance to go through their presentations first. And again, thanks a lot, Ben. I think that was a great introduction to tidal energy and some of the potential for some of our remote communities. I'm really pleased now to welcome Marek Jakinski as the second speaker. Marek is Director of Development Alaska with ORPC. As a lifelong Alaskan, Marek works with local regulators, communities, and electrical providers to develop tidal and river-based energy projects for ORPC. Marek brings his familiarity with the traditional way of life to the technical and logistical aspects of project development through his background in contract negotiation, construction management, and engineering design. Marek will tell us about a remote tidal turbine project his group is leading in Alaska. So over to you, Marek.
Thank you for the introduction on that. And I do have my slides being ran remotely. I'm working from my phone, so hopefully the connection works well throughout this whole presentation. I am currently in Igiugig, Alaska. We are actively working on deploying our second device, as you can see here on the screen. If you could go to the next slide, please. Next slide, sorry. So little background on ORPC. ORPC is based in Portland, Maine. We do have offices in Montreal, Anchorage, Alaska, and Ireland. And recently we just opened an office in southern Chile as well. We have about 35 employees. We're in the process of expanding ORPC's capabilities through hiring new folks in to bring in different talents into the business development side of a business. Our products are exclusively related to capturing tidal flow. So we don't do anything with wave power. We don't do anything with tidal differential. Everything is based on the flow. So, you know, in relevance to this conversation we're having now, the velocities that are created from the tidal movement is what we use to capture that power. And ORPC, of course, you know, part of the reason the company exists is a lot of the new mandates around the changing world and the kind of this climate change that we're going through right now. We're wanting to create clean energy jobs and also stand for equity and environmental justice as we grow as a company. Next slide, please. So ORPC has 4 products that are currently in the product pipeline, if you will. We have a base technology that is used for our main 3 components, and that would be the modular RivGen, the RivGen, and our TideGen device. The common components, of course, in this case are the hydrofoils, the drive lines, the generators, the bearings, the brakes. And those are designed to be that way so that devices can be scaled up or down and put on different platforms fairly easily. So as you can see on the left-hand side of the screen, the modular RivGen is basically a 2-stack turbine array. The RivGen is a side-by-side turbine array, and then the TideGen 80, if you can see closely on that little helical mess there, there's actually 4 turbines inside that. And then, of course, our last device, which is under development as part of our growth with the company and also with the European Union, is what we call our Optimor device. And that is designed to be a kilowatt scale device, or sorry, that's designed to be a megawatt scale device, whereas the rest of our devices are actually kilowatt scale devices. And we are actively looking at projects throughout Western Canada, Cook Inlet, Alaska, and Southeast Alaska with these, as well as some other places in Europe. Next slide, please. So part of the reason for having that common platform allows us to work more realistically with small communities. Ben kind of touched on it on his presentation as well, that some of these communities are islanded, hard to get to, or what have you. So part of the design for ORPC solution is to have something that's more modular. The RivGen itself, as you can see in the bottom corner there, that fits into 4 flatbed trucks. Where I'm working at in Igiugig, that was brought out here on a barge and had to be brought across Cook Inlet. We are anticipating as we scale up that we'll have that same capability with the rest of our devices and be able to have that common design going forward. Next slide, please. Really quick, I'm going to delve into what I'm actually doing today and where we're planning to go with the technology for ORPC. Next slide. So we are working in Igiugig, which is the traditional ancestral land of the Igiugig people. I myself am a Alutiiq descendant, and so it's very nice for me to be working kind of in the same area regionally that my family history is from, and also bringing some new technology to the site. So it's very, very satisfying, I guess, to have this this kind of a position. We are currently installing 2 RivGen devices, which is that first device that was shown on the very front page there. The project site is a little bit downriver. Igiugig is based on the back end of Lake Iliamna, which is the largest lake in Alaska. So the entire lake flows through one river, which creates a very tremendous velocity. What we've done here is we've trucked everything out and built it on site. And devices are then pushed down the river, anchored in stream, and then lowered down. And the ultimate project is to have 2 devices installed along with a smart battery energy storage system, which I'll expand on later on in the presentation. And that will bring the village diesel use to a reduction of 60 to 90% with having that battery energy storage system online. So it's a very high goal, and it's a very achievable goal for this community as well. And of course, the implementation of that battery energy storage system allows more renewables to come on the grid, such as solar and wind. Next slide, please. So just a quick overview, and there's a video link on here that unfortunately this doesn't play, but if you want to drop that into the chat, I'm sure that folks would be happy to watch that. It's just a little quick video of the RivGen spinning. Our device sits on the riverbed. It is just held in place by a drag and bebbet anchor. It has an output of about 40 kilowatts where it's located at. It's a fairly sizable device. It's 15.7 meters across, and it does have a walkway on the back so we can actually get on and access the turbines and the generator and the brake and everything else on there. It's been in the water for 21 months. We actually just pulled it out in August to do some refurbishment work as part of a grant through Department of Energy in America. There have been 2 winters we've gone through here. One winter where the ice actually froze over the top of our device. We had another event with some Brazil ice on that actually, you could see it accumulating on the turbine through the cameras. So it's been a pretty tough go for this device, but it's still operational and still working. And of course, we're putting in our second device right now. So it's proven to be a robust technology and able to withstand some harsh winter conditions. Next slide, please. So Igiugig itself is currently operated solely on diesel. And if you recall from the first slide where I showed the village, it's right along the river, and that river is home to one of the largest salmon runs in all of Alaska. All of their fuel right now is currently flown in. The river at some points further downstream is too shallow for barges to make it up, so fuel has to be flown into the site. You can see in that bottom picture that it's quite impressive that that large plane can make it to the small runway that's out here. And unfortunately, that's just something that they've had to deal with as civilization's advanced and electrical demand has increased. And so helping this RivGen come into their community has been of great benefit and reduce their fuel usage quite a bit. Next slide, please. So part of ORPC's strategy was to develop the device to be built in concert with the community. We're not staffing welders, we're not staffing, construction, heavy equipment operators, we're not staffing barge captains. We're working with the existing local infrastructure. So there's a whole base of talented people in remote communities that wear several hats, and that's the same for places in Western Canada and also Northern Territories as well. So with that in mind, it's there's me and 2 other folks here from ORPC that kind of just help with supervising and everything else, and everything is mostly done with the local community, and that really drives ownership of the device. And when you build something yourself and maintain it yourself, I think there's a lot more pride in ownership, and also pride in having that device operating and keeping the diesel off. Next slide, please. So the RivGen, when it comes up, you can see here we actually have a umbilical cord that hangs off the back. That's my coworker Matt on the left. We were raising it last year during COVID. We came out, just me and him. We were basically isolated from the community, so it was a fun maintenance cycle. You can see here there's a walkway that's on the RivGen, so when you go on there, there's access to all the main components. Of course, this is designed for in-river. The thing I guess to keep in mind is that the RivGen itself turbine section will spin the same direction regardless of where the flow is coming from. So in a tidal location, if a RivGen were deployed, potentially with a different pontoon structure, but if it were deployed there, the tidal cycle would still be able to achieve its max output from that. Next slide, please. And just lastly, I touched on this earlier, kind of what the ultimate vision is, and this is something that not just ORPC, but a lot of folks are striving for these days, is to kind of have this smart microgrid solution going forward, where you can see there's a battery energy storage system that goes into a smart microgrid controller, some kind of a energy source, whether it be diesel, whether it be a tidal source or a river source or a wind source or a sun source. Those devices can all be put into the battery energy storage system, and then those batteries become the grid forming system for the village. And that's what our focus has been on this, and we're vetting that out right now. We actually have our second RivGen installed. We're working on getting the battery energy storage system up and running. Of course, we're waiting on some permitting to come through so we can finalize installation with those devices. But once that happens, we're expecting to be in that 60 to 90% diesels off period for the village. So it's an exciting time for ORPC. It's an exciting time for the tidal industry because some of this technology is applicable and repeatable back in tidal locations. And I didn't have any slides on this, but I'll just touch quickly that ORPC is also working on some tidal deployments throughout Southeast Alaska and in Western Canada. So we're hoping to keep up the momentum we have here with the RivGen and extrapolate on that in further areas. And I believe one more slide, that should be the end. And I'm happy to take any questions at the end of the presentation. So thank you.
Thanks a lot, Merrick. That was really interesting. And I think I wrote it down, the RivGen system is a very exciting technology. So thanks for sharing that. We'll go on now to our third speaker, Bob Anderson. Really pleased to welcome Bob here today. Bob is the VP of Business Development for Canpac Marine. Bob is intimately involved in the business goals and directions of the company, with a key focus on the company being a major participant in the renewable energy market for British Columbia. So thanks for joining us, Bob, and over to you.
Thank you very much. Can you hear me okay?
Yes.
Perfect. I think we've had an excellent 2 presentations by Ben Whitby with Primed to be able to introduce the phenomenal tools that are available from a research perspective in deploying renewable energy Merrick with the ORPC introduced a very strong technology that can be used up and down the coast of British Columbia. And then third, our goal is to introduce, well, who installs it, who can service and support it when it goes on there. So giving you 3 unique and distinct roles and responsibilities in the deployment of renewable energy. Just to give you a snapshot, Canpac Marine, we've been providing marine services, subsea services to inland, coastal, and offshore sectors since 1980. If you saw a picture of what we wore back in those days, things have changed. We're an accredited company, unionized. We ensure that we've got full operation under the ISO rules and regulations for operation, and all of our and full IMCA certifications for the organization. This ensures that we have minimum, or let's say, we can replace and redo programs repeatedly and try and do it as cost effectively as possible for operators, etc. We've had over 100,000 man hours of underwater services without a single lost hour, 1 hour to anybody being hurt or on a project. One of the big project aspects of our company is installing power and communication systems for BC Hydro, for the telecommunication companies as part of our overall programs. And in that you'll see how that's helped benefit us for a project coming up. We are very, we invest substantially into the organization with new assets and resources. In fact, have some of the most advanced dive and cable laying assets on the coast today. We are a 24/7 operation, 365. So, boats are coming in, ships are coming into the West Coast, projects are happening, emergency, a ferry could get damaged somehow. We've got to be able to deploy resources and assets immediately up and down the coast. So it gives you a quick snapshot of the company's background. I'd like to introduce you to a project that's happening right now on the West Coast, starting with installation of a fiber optic cable between Prince Rupert and Haida Gwaii. That starts roughly November 8th for installation. But overall, we'll be installing roughly 3,400 kilometers of fiber optic cable up and down the coast. I wanted to include this in our presentation to give you an idea of the change that's going to occur to the user communities that are out there. We will be landing this fiber optic cable at roughly 180 shore landings. And some of these resources are all diesel powered and First Nations, and they'll be able to run fiber optic cable communications, be able to take university courses, be able to learn, and in fact participate in presentations like the very one we're involved in today, and be able to increase the knowledge base for these user communities. There's nothing like a knowledgeable client. And with that, we will see the opportunity to drive themselves onto a green initiative is going to help substantially. And that's why I think that the demand for products will improve. Obviously, with the BC Hydro and the completion over the next couple of years of Site C, will help bring a focus more towards expanding and deploying assets that are not part of the major grid, but are lower cost or of equal cost. Canpac's actually been involved in the kinetic energy business since 2006. We were participants in the Race Rock turbine. That's the first kinetic energy project in Canada, and very high speed, very currents running through that facility, 5 to 10 knots of power. The belief then was higher speed, more power, which in the case of ORPC, they give max power generation at 3.5 knots. So the efficiency of the technologies improved dramatically. In the case of the picture you see on the screen right now, the water wall turbine, that sits on the surface, and the propellers are then driven by the current direction. And it had major forces put on it. That structure, which is basically the size of a house, was hit with roughly 100 tons of current force, changing 4 times a day. It's also located 900 meters from the power storage distribution center. So a lot of technology was used on that. We want to kind of take a look at that a little bit further, in that these people, specifically Navient Innovations, who developed that technology, were innovators, no doubt about it. Same with the Race Rocks clean current power systems. So British Columbia has a phenomenal amount of, should have a lot of pride in the pioneering of these types of technologies. If we look at Race Rocks, one of the fastest and highest speed currents going by just off of Victoria, you take a look, that turbine sat 22 meters below the surface of the seafloor, and or below the surface, about 20 meters above the bottom. And both projects were installed successfully. We've got to admit that they had challenges, technology challenges, and over the years, last 5 years to 10 years, the technology has improved dramatically. When you're deploying tidal turbine type technologies, when you install them, you got to take a look at what's the local knowledge about the conditions. In the case of RibGen, frazzle ice is a key issue. We see that when we're doing dam work all the time up in the Yukon. They get hit with frizzle ice, and you could be pulling ton-sized blocks of ice out of the river / water stream. What type of currents do we have here? In some cases, looking at the Juan de Fuca Strait, you have dural, semi-dural, and in some areas mixed semi-dural. So you take a look at the direction that the turbines will be turning, or how they will be impacted. They can change quite a bit, and how it's a frequency that you didn't expect. As I mentioned earlier, the technology is improving dramatically. If you look at the RibGen product, that can give peak power at 3.5 knots. That's a phenomenal improvement in performance area. Mentioned earlier, the distance from the turbine generator to the client's microgrid, that's important. How far is that cable? How will we protect it? Sometimes you'll have rocks running down a river that you have to be concerned with, and will they impact the technology or the cable, or how do you protect it from anchors drawing on the power cable? Next is security. How do you protect it security wise, and how, if something does happen, how fast can you get in the mobilization of marine assets and personnel? RibGen's or ORPC's approach to use local resources as much as possible is a very smart way to be able to protect their technology. In doing a project consideration from a Canpac perspective, we look at and say you need to be considering, first of all, your feasibility studies. As you saw, Mavi did some work for NRC on a site, very extensive bathymetric and acoustic Doppler research to be able to tell, okay, where's a good site to put power generation systems in? And we, as installers of that type of of the equipment, would then use that, or we would provide it to clients in order to, is this a good place to go? And that's, do you need to put it into deep or shallow scenarios, which also then dictates the type of anchors and the quantity that you'll be put in. If we look at the challenges of some of the previous sites, be it on the west or east coast, anchoring has become one of the major faults, and not putting enough money into that particular area. And if you look at the stress, it will repeat again. You take a look at what the stress went on the water wall. That's over 100, phenomenal amount of power that it had to keep up with. Inspection, repair, and maintenance, the frequency of it. How easy is it to get to? How fast can you get to it and do any repairs or maintenance that needs to be done on it. If you take a look at the bottom right, that's one of our assets, the Canpac Valor. It's a DPI dynamically positioned vessel. It can stay within a station keep within 1 meter up to 5 knots of current. This gives us the ability to drop anchoring systems off her into the current and do it at a single sweep, lowering costs, making it more efficient. In areas that we can't bring a ship that size, we may bring in ships like the Canpac Ruckus and have divers go down and perhaps drill the rock. And a lot of times that's what you have on the bottom. If the flow is fast, it's going to be a lot of solid rock. And lastly is, we know that you're going to need to have dive and ROVs surveys, marine construction firm. And basically, from a perspective of Canpac, we take on the full responsibility there, one hand in the fire per se. So we do the installations and the certification and then the maintenance of those sites. The goal in this presentation was, well, who does it? How do they do it? What are the considerations that they apply on? What's the expertise they need to have on hand? And trying to stay away from a sales pitch, the idea here is there's a lot of growth opportunity here, and we look forward to participating over the next 5 to 10 years in the deployment of these types of assets and power generation systems. And that's the presentation. Thank you.
Thanks very much, Bob, and thanks to all of our panelists. I'll now invite you all to turn on your videos. And we have a few minutes left for questions. I'm just going to take a look at the questions that we've gotten from the audience members. There were a couple of questions about what makes a site suitable for tidal power turbines, or does there need to be a threshold? And I think, Bob, you already answered some of those questions about selecting a site and some of the challenges. So maybe to start us off, Ben, I'll go back to you. There's a question submitted by Connor that is about power production. And the question is, the power production at Blind Bay was very different between winter and summer. Is this simply a difference in tidal flow over these seasons, or are there other factors at play? And you might need to unmute yourself, Ben.
Sure, sorry about that. Yes, I'm not sure if he's getting that from one of the slides, and he may be mistaken because that slide was actually showing demand, power demand. The tidal flow at the site, there aren't significant differences between the seasons. But certainly the load at Blind Channel, the demand for power does vary significantly from season to season. So the peak demand at Blind Channel is in the summer months when most of the visitors and the tourists are on site. During the winter months, the demand drops to below 20 kilowatts actually, and the peak summer demand is in the region of about 80 to 85 kilowatts. But in terms of the tidal resource, that's fairly consistent throughout the year. So no, that doesn't vary between winter and summer really. It's obviously correlated with the moon and the sun and their relative position, and it's actually highly predictable, which is one of the things that is a major advantage. You can predict the amount of tidal power you're going to get potentially years in advance. With the right models, etc. So yeah, I think that answers that.
Great, thanks, Ben. That's actually reassuring, because I think we wouldn't want large discrepancies across the seasons, because if this technology is going to be useful, I think those communities would be looking for consistency over time. So that's reassuring.
Absolutely, and that's one of the benefits. Yeah, it is predictable and consistent, unlike your solar or your wind. So yeah.
So maybe then, just staying on the theme of site-specific questions, Bob, I'll go back to you. There was another question submitted by Connor, and he's asking, if there were any environmental issues or concerns with the Race Rocks turbine, given that the site is an ecological reserve and home to a lot of pinnipeds over the winter.
That's actually a very good question. In fact, every site is concerned about the impact to the local flora and fauna. And I mean, it's just even to sites that say, well, what's going to happen with the crabs? You know, are they going to be able to go across or sit around or grow or adapt? In the case of Race Rocks, the issue of the large home for pinnipeds, or you know, was a key one. I think even Merrick has a video where you see salmon going through the blades and working their way safely through the blades successfully and safely with no impact. Because the Race Rocks was an open design, video showed that not as much as pinnipeds, but definitely organisms of life was able to pass through the system without being negatively impacted. So there is concern. Every site has that concern that it will happen, that there'll be an impact on it, but it's turned out that it's minuscule or not a major factor in the decision process.
Great, thanks, Bob. And I'm going to go now to a question that's a little bit more general, and I'll turn first to you, Merrick, but then invite our other panelists to weigh in after if they'd like. And this is an interesting question, I think, because the work that you're all doing is impressive, not just for the technology it's advancing, but for the impact that it's having on society, on communities and the societal impact. And so there's a question here about how you build teams to work on these projects. I think people are excited and maybe they want to know how they could get involved. So Celine has asked a question, and her question is, in order to build teams to work on such projects, what type of talent or technical skills are you looking for? And Merrick, you had talked about going on a maintenance call and just having you and one other person, but is that typical, or do you really need a broader team to take on these projects?
Well, yeah, that's a good question. So, you know, my background, I grew up commercial fishing and then went to college for engineering. So I kind of have a varied background when it comes to mechanical maintenance and also some of the technical aspects of things. But, you know, ORPC, we have folks that are, you know, strictly software engineers. We have folks that are, you know, strictly mechanical engineers that do some of the dirty work and the testing and things of that nature. And then, of course, we also have, you know, people in executive positions that are more in line with, you know, business to business sales or transfer of products and technologies and things like that. So there's a wide array, and really the industry that we're in has very applicable existing jobs that are out there. I know some people compare us to oil field. You know, there's guys in the oil field that work as a roughneck, right? They go out there, they, you know, bend wrenches, turn things. Well, I'm doing that today. We're installing turbine sections today. So we're hitting things with the, you know, torque wrench, and, you know, we're binding things down and stuff like that. So there's a wide range. And as the industry expands, that's only going to encapsulate more types of talent that are out there. But I would say the big thing is be willing to have curveballs thrown at you. If you want a industry that's stable and existing, you know, there's other things that are out there. The kind of the stuff that we're working on is new challenges every day. You know, Bob hinted at frazzle ice. That's a huge thing that I didn't know about until I worked at ORPC. Seeing the tremendous force of the water is just always impressive out here. Getting my hands dirty with some environmental monitoring things. Last year, I was out here working with Alaska Department of Fish and Game, doing some of that monitoring. So there's a varied talent base that we work with.
Anybody else? Ben, Bob, anything to add?
Yeah, I mean, I can come in quickly. I mean, I think I kind of touched on this when I introduced Primed. I sort of emphasized the fact that we are very much a multidisciplinary research group. And I think that's true. I mean, we have people working with us who have oceanography and marine biology backgrounds, right through to the people like myself. I'm an electronic engineer. We've got mechanical engineers in the group as well. So it is very multidisciplinary. And you definitely need that if you're going to do the scope of work that we're doing, sort of taking projects right from the pre-feasibility stage, where you're assessing the resource, you're assessing the potential environmental impacts, right through to deploying and operating devices and integrating them into the power network. So yeah, it is definitely a multidisciplinary topic, and I think our group shows that more than any other, really. Yeah.
I would agree with Ben and Merrick. The growth opportunity will be driven by, in the case of British Columbia, from my perspective, by BC Hydro's participation, and at the same time, the growth of the demands by First Nations and other diesel-powered facilities to demand to get off of oil, to get off carbon-based technology. And as that grows, as demand grows there, the recognition, the work that's been done, research that's been done by Ben's teams and Merrick's organization, those are types of organizations, and the MAVIs and the others all enjoy or grow our knowledge of what the sea does to this. At some point, we at Canpac see the growth of and it's perhaps competitive to kinetic energy, but see the floating windmill wind farms being mounted in British Columbia off the coast. We are involved in looking at what the sea bottom will require to hold those assets in place when the Pacific Ocean gets mad. And we need to be able to look after that, right to the small, cost-effective deployments in small sub-megawatt or kilowatt type environment. So definitely the growth in every aspect, bathymetry, seismic, every aspect of research that goes on. So scientific and mechanical knowledge base will be in demand and is in demand.
So thanks, Bob. And we're running short on time, but I'm going to try to squeeze one more question in. I see a couple of questions in the Q&A box around cost, and I had one that I wanted to ask as well. So I'm going to kind of combine all of these into one. And really just reflect that obviously BC has relatively low electricity prices. And we know that right now tidal energy is really a significant higher cost per kilowatt hour. So the question is, do we need government intervention or support here? What do we need in order for tidal energy to become a reality? What kind of investment is it going to take to really move this forward in a big way to support these communities and move them off of fossil fuels and onto this kind of renewable energy source?
Yeah, so I can try and give an answer to that. I think it's important to make a distinction between the off-grid projects and the grid-connected utility projects, because they're both going to have different cost models. For your grid-connected projects, yes, tidal energy is not competitive at the moment, and you're going to struggle in BC to get a power purchase agreement as a tidal energy developer, simply due to the cost at the moment. Without a subsidy, and there currently isn't one. Yes, you mentioned the low cost of hydropower, etc. It's very difficult to compete if your sole purpose is to sell power into the grid through a power purchase agreement with BC Hydro. And that's really why the focus on BC is at a smaller scale, looking at these off-grid diesel-based communities. And it is a lot easier to develop projects in those areas that do have reasonable payback times. So the time that it would take that community to recoup its capital investment is a lot shorter. And also the cost is actually on a par because they're already paying a significant amount of money for that diesel generated power. So it is possible to achieve parity there, despite, you know, tidal still being relatively high. And that just emphasizes the point that these communities are already paying, you know, over the odds. Yeah. So yeah, and you also need to consider the the additional benefits as well. And that's going to vary from community to community. I gave Blind Channel as a case study, and they are looking at this not only as a way to reduce their fuel costs and reduce diesel usage, but also, you know, to reduce their carbon emissions and portray a greener image of themselves. And in First Nation communities, you know, environmental impact is also a concern. So there are the non-tangible benefits as well that tend to play a bigger role when you're connecting into these off-grid communities. So yeah, in summary, it's viable at the community off-grid level. If you're looking to move to utility grid connected scale, then that's only going to be viable with subsidies, certainly.
Thanks very much, Ben. And I think in the interest of time, I'm going to leave it here, and I'll just say thank you very much to the three of you for your wonderful presentations and for taking the questions and providing answers. Hopefully it's been a great session for everybody. I certainly learned a lot, and I really appreciate the three of you taking your time today. And Julie, I see you're here, so I'll turn it over to you for closing remarks.
Thank you. Thank you to you all, and thank you to you, Dr. Lisa Kalinchuk, for moderating this panel. And thank you to everyone in the audience for attending. For November, we'd like to encourage you to catch up with COAST members at Rising Economy Week 2021, which is November 23rd to 25th. And you can learn more about that in Canada's our coast at canadacoast.ca, and you can also view past talks on YouTube. So please do head over to our website, and you can also find out there about becoming a member. A membership is free for a limited time, and early members have an opportunity to help us build a clean tech innovation hub here in southern Vancouver Island and throughout the BC economy. So thanks again for joining us, and see you next month at Rising Economy Week.